For example 10, a cylindrical beaker with a radius of 10 centimeters is being drained at a rate of 25 centimeters cubed per minute. Find the rate at which the depth of the liquid is decreasing. Well, what do we know? We know that this is going to be cylinder. We know the radius. We know the rate it's being drained at. So that's going to be a negative rate. And we're trying to find the rate for the depth. Well, if I think of a cylinder, I have the water in here at whatever level it's at. Then based on the shape, we're going to have the radius. We're going to have the height, and in this case, the height will also be representative of the depth. And I know that the volume of a cylinder is pi r squared h. Well, this one's interesting because in this case, we have the volume, we have the radius, and we also have the height. And we're still doing this over time, which means that we actually have more variables than we usually do. Now, what do I know? Well, I know from what was given that we're doing it when r is equal to 10 centimeters. We know that dv over dt is equal to negative 25 centimeters cubed per minute. And we know that we're trying to find dH over dt. Well, we've never had to do it with 4 variables before, v, r, h, and t. But we're still going to use the same principle that we have. We're going to state that if we're using the volume of the cylinder is equal to pi r squared h, the thing that's unique about this case is no matter how much the water goes up and down here, the radius is never changing. So it's only the volume changing in relation to the height and time, obviously, which means that the volume is a constant. Sorry, the radius is a constant. So I'm going to say that the volume is equal to pi times 10 squared times h, which means the volume is equal to 100 pi times h. And then I'm just going to take the derivative of this, which is going to give me dv over dt is equal to 100 pi, and then dH over dt. Well, now that I've taken the derivative, all I have is just the dv over dt and the dH over dt, which means that when I sub in what my dv over dt is, negative 25 centimeters cubed per minute, then I can very easily isolate the dH over dt. I'm just going to divide both sides by 100 pi. And I'm going to get negative 1 over 4 pi. Because I'm doing this in terms of height, my units are going to be in centimeters per minute. And then I can just make my statement. The depth of the liquid is decreasing at a rate of 1 over 4 pi centimeters per minute for a radius of 10 centimeters beaker.